Researchers looking for alien communication once found exactly what they were looking for, only for it to never be found again. In the early 1960s, researchers at Ohio State University built a radio telescope called the Big Ear. It was fully operational by 1963, and it wasn't a dish. It used a tiltable, flat reflector to bounce radio waves onto a fixed parabolic reflector, which focused them into two feed horns mounted side by side. The telescope sat bolted to the ground and let Earth's rotation sweep the sky past it. The software, written by Jerry R. Eman and Robert S. Dixon, recorded 50 channels, each 10 kHz wide, every 12 seconds, using an IBM 1130 computer. The setup centered around 1420 MHz. They chose this frequency based on a 1959 paper published in Nature. Cornell physicists Giuseppe Ciccioni and Philip Morrison proposed that any civilization advanced enough to communicate across space would choose this frequency, because it's the frequency at which hydrogen, the most abundant element in the universe, naturally emits a faint signal. The reasoning was that any technologically advanced civilization would know this frequency, making it a universal meeting channel on the radio dial. To this day, 1400 to 1427 MHz is internationally reserved for radio astronomy. The Big Ear sat on the rotating Earth, measuring whatever direction the sky drifted into its beam. With two horns, each pointed in a slightly different direction, a celestial source would pass through the first horn's beam, then, about 3 minutes later, through the second horn's beam. A real signal from space would appear twice, once in each horn, serving as a kind of built-in confirmation. But there was a catch. Software didn't record which horn detected what. Usually that didn't matter. You'd see the signal twice and know both horns had picked it up. This would become a problem later. On August 15, 1977, at 10:16 p.m. Eastern Time, the telescope sat measuring, unattended. No one was present. It picked up something strange, a sequence of characters, 6EQUJ5. This was not an encoded message. It was an intensity code, measuring how loud the signal was across 6 successive 12-second measurement windows. At its peak, the signal was 30 times stronger than the background noise. It lasted for exactly 72 seconds, the full window the telescope had to observe the part of the sky before Earth's rotation carried the source out of its beam. Days later, while reviewing the printout data, Jerry Eman discovered the anomaly. He circled the characters and wrote "Wow" in the margin. That's how the signal got its name. This had all the hallmarks of what they were searching for: a narrowband signal, near the hydrogen line, rising and falling exactly as a real extraterrestrial source should as it drifted through the telescope's beam. Or, at the very least, something extraordinary emitting a very strong signal from the direction of the constellation Sagittarius. Eman and Dixon tried to pinpoint where the signal came from, but there was one problem. Only one horn had recorded it. A real celestial source should have appeared in both horns. Since the computer didn't record which horn detected the signal, there were 2 distinctly different locations it could have come from. They tried to recreate the observation over 30 times in the weeks following the detection. Nothing. In the decades since, the VLA in New Mexico, the Green Bank Telescope in West Virginia, the Allen Telescope Array in California, and Breakthrough Listen have all pointed their instruments at those coordinates, far more sensitive than the Big Ear ever was. In May of 2022, the Green Bank Telescope and the Allen Telescope Array coordinated a joint observation specifically targeting the WOW signal's possible source. The result? Nothing. To this day, nothing has been detected. Not once, not ever. And there's something else. The Big Ear telescope itself is gone. In 1998, the land was sold to developers, and the telescope was torn down to make room for a golf course expansion and housing. We can't even go back and look with the original instrument. So, what is it? Alien communication? A nearby comet? A secret satellite? Something else? Over time, many explanations have fallen away. Space debris reflection? Low probability. Comets? Discredited, because comets don't emit strongly enough at 1420 MHz. And they weren't in the beam at the right time. Interstellar scintillation, the radio equivalent of stars twinkling, could theoretically amplify a weak signal, but it's considered unlikely. And the VLA should have caught it. Terrestrial interference, satellites, spacecraft, all ruled out. That leaves 2 hypotheses standing. One, a rare astrophysical event, a hydrogen maser flare, where a cold cloud of interstellar hydrogen is suddenly pumped into emitting a burst of energy at 1420 MHz. triggered by something like a distant magnetar flare. It's an elegant explanation, but no 21-centimeter hydrogen maser has ever been detected in space, and the 2024 paper proposing it has not yet been peer-reviewed. 2. Perhaps we're not alone. Jerry Eman himself put it best: I choose not to draw a fast conclusion from half-vast data. But for 72 seconds in 1977, something out there answered back, and we've been listening for it ever since. If you like forgotten radio history stories like this one, subscribe. The next one is about the man who heard the entire galaxy with a telephone company antenna. Thanks. Bye.